This is part 3 of our video series for chapter 3 on the least squares regression line. Here are just a few general ideas about a regression line. It's any straight line really that helps to describe the relationship between two variables, and the line itself is used to make predictions for the response variable for any given value of the x variable, and it serves as a model for the data that we have. There are many different types of regression lines. You've dealt with the median line. There are lines where we can choose the lowest points and the highest points and find the equation and draw the line between those 2 points. But in statistics, we deal with the least squares regression line. And that's the one that minimizes the error, which we'll come to know as residuals. So it makes that error as small as possible. As we can see here, the equation is y hat equals a plus bx. Make sure you keep the hat on top of the y. That shows a predicted response as opposed to one that we've already observed. A is the y-intercept and b is the slope. And I've just listed this here down below. Y hat is the predicted value of the response variable y for a given x. B is the slope. This interpretation is important. The average amount by which y is predicted to change when x increases by 1 unit. We'll do an example that uses this later on and also tomorrow in class. A is the y-intercept, the predicted value of y when x equals 0. Now, of course, we can do this on our calculators. I'll be showing you that tomorrow. But also, sometimes you're just given summary information and not the data itself. And so it's important to know how these constants are related in this equation. So we can always find the slope by taking the correlation coefficient, which is r, and multiplying that by the proportion of the standard deviations y to x. We can find the y-intercept by just substituting x bar and y bar into the equation. Those represent the mean of the x variables and y variables, and that ordered pair is always on the regression line. Residuals is just another word for prediction error. Because we're making predictions, we are going to be wrong, and so the residual is a value that shows us how far off we are based on observed and predicted. So we use y minus y hat, where this is observed minus predicted. We can make residual plots, which we'll talk about more tomorrow, and what the residual plots help us with is that they're used to check how well the regression line actually fits the data. And whenever we see a pattern in the residual plot, that suggests that maybe a linear relationship is not present and we should seek other avenues. These are the different types of patterns that you might see in a residual plot. Curved dots, increasing spread across x, points with large residuals, or points that are really extreme in the x direction. If we see these again, we might want to think again about using a linear model to describe our data. So I've provided some information here for you. You should recognize this example. It's also from the last video where we have our airlines that have been outsourcing their planes for major maintenance, and then the percentage of delays that have been blamed on those airlines. I've given summary information here at the bottom. The top number is the mean, second number is standard deviation, and the bottom number is the correlation coefficient. So we're asked to find the equation of the least squares regression line for predicting delay percentage from outsourced percentage. And so we'll use our formulas from before. We'll begin with finding B. So to find B, I need to take the correlation coefficient and multiply it by the ratio of the standard deviations for x and y. So this just becomes 0.48. And I'm rounding here from this 0.476454. And we're multiplying that by 14.66 over 18.05. And again, that's the standard deviation of the y value divided by the standard deviation of the x value. Now when I do this, I find that B is equal to 0.39 roughly. That's rounding. Then I'll need to find a value for A. To find A, try this again. I'm going to take y bar and subtract B times x bar. So y bar can be found here, 29.93. X bar is here, 65.14. And so this becomes 29.93 minus 0.39 times 65.14. And after using my calculator here, I find that this becomes 4.52. And so the equation I would write, assuming that x is the outsourced percentage and y is the delay percentage, is that y hat equals the y-intercept, which is 4.52, plus the slope, which is 0.39, times x. Now if I want to interpret the slope and y-intercept in context, let's first begin with the slope. We're just going to go back to that very basic definition of increase on average based on prediction from the regression line. So, on average, for each additional percent increase in outsourced planes for major maintenance, we predict an increase of 0.39% in delays blamed on these airlines. That is our interpretation for the slope. If we want an interpretation for the y-intercept, we just need to think about what a y-intercept is. Whenever x equals 0, it is the value that y takes on. And so all that means for us is that when airlines do not outsource their planes for major maintenance, that they are still blamed for about 4.5% of delays. So again, when airlines do not outsource, they are blamed for about 4.25% of delays, which says they're going to get blamed anyway. So that's the price that they pay for being in business. Now I want to show you how to make predictions and also find the residual associated with the percent of delays. And you will need to key these two numbers into the feedback form so that I know you watched the video and I can ascertain whether or not you really understand what's going on here. So I'll set it up and I'm going to need you to finish it out. To make the predictions, you're going to begin with our equation. Y hat equals 4.525 plus 0.39x. And x, remember, is the percentage of outsourced planes. So you're now going to take this 76%, plug it in for x, and then give me a value for that. So I need you to key that into the feedback form. In order to find the residual, keep in mind residual is y observed minus y hat predicted. You have the observed value for 76. You can get that straight from the table. And you have the predicted value from above. So what I will need you to do is to take your observed minus predicted and key that number into the feedback form. And you're going to round that number to 2 decimal places, and I will remind you of that on the form. So this just gives you a quick oversight. Tomorrow in class, a quick overview, Tomorrow in class, we'll do some more work with this, and we'll continue with our Fathom activity. Certainly, if you have questions, feel free to email me, and I'll see you tomorrow.